Share this with the cleverest person you know and see if they can solve it. Here's a grade 9 question. This is similar to the hardest question on the GCSE paper when I sat it. Here is where most students freeze, and here's the question, here's the setup. You have a spaceship orbiting the Earth in a perfect circle, right? This is how NASA lands its spaceships on the moon. This is how they do it, right? Perfect circle around the Earth. It leaves at a point of minus 61642350, and it shoots off along a tangent attached to that circle. The spaceship leaves orbit, and its target is 12,000, 50,000. The question is simple. Does it hit the target, yes or no? Only a small portion of GCSE students actually get the right answer, so can you? Pause right now, write your answer below. Does it hit or does it not hit? So here's the setup. Step 1, find the radius. So the radius is going to be from the center point to that exit point, and you're going to have to do rise over run to find the gradient of this line here. Now, what we do is we find the negative reciprocal of this, we flip the fraction, and we put a negative sign. Why? Well, this helps us find the perpendicular gradient for our line, that line that is shot off at, which is going to be y equals mx plus c, which we know the gradient for, m. However, we don't know c. How can we find it? Well, what we do is we substitute in point x, the exit point x, and point y, the exit point y. You substitute that in, you have y equals mx plus c, you know y, you know x, and then you can find c. You have the full equation of the line. Now, what do? What you have to do is then you substitute in your target point, your target x and y, and you see if c is the same as the other c. Why? Well, that means that your lines will be the same as each other. Now, don't worry if you didn't get that at all. That is a hard question, the final question on the GCSE paper when I sat it. And if you want to learn the shortcuts to understand something like this in a bit more detail with me, we can go through it together in a completely free GCSE session with me. So click the link in my bio and let's book that with you right now.